So you've seen us make tablets in the manual tablet press. This is a laboratory rotary tablet press, which is much more similar, though smaller in scale, to a production machine, but you'll notice some of the same features as the manual press. So for example, there will be these punches moving in and out of dies that will then compact the tableted material. Then in place of my spatula feeding material onto the die, we'll have a feed frame that can actually move material from a hopper into the die. There'll be a strike off back here that will then level it to make sure that the amount of tablet fill is consistent for consistent tablet weights. And then instead of my hand or a hammer, the compaction force will be set by these rollers here that push the punches together to the minimum distance, and how much fill and the distance set will dictate how much force is applied on that material when compacting the tablet. Finally, these tablets will move around, and there's a takeoff here where they can fall down to the chute and be collected. When producing tablets, there are a couple key parameters that need to be evaluated. The first is you want to have the right tablet weight, because that's actually going to set the dosage of active that the patient will receive. The second parameter is you want the tablets to be sufficiently hard for the application. So for a chewable tablet, you would want a much softer tablet that's not going to hurt your teeth to chew. But in the case of a tablet that you're swallowing, then you want the tablet to be much harder, so that if, for example, it's in a bottle, as is often happens in the US, it's hard enough to be moved around and rub up against each other without breaking apart. So the first thing you're going to have to set is your weight, and this is primarily by your fill depth in combination with your powder properties. So first you will simply produce some tablets, and then you will weigh them and see if the weight is correct or if you need more or less powder. So I'm going to measure here, collecting 4 tablets. I'm now going to put these on the scale, and I see that I have less than 1,600 grams. Because I'm targeting 400 milligram tablets, I in fact need to be targeting 4 tablets that should be 1.6 grams. So I'm going to increase my fill depth over here so that I can get more volume of powder. The fill depth is how much that lower punch is moving to allow powder to fall into the die. So as I increase the depth that the lower punch lowers to, I increase the amount of powder that can go in, thus the tablet weight. So let's see what weight I have now. Okay. And these ones weigh, pretty good, 1.59 grams. I can tweak a little further, but for the purposes of demonstration, these are approximately 400 milligram tablets. So now that we've got the tablet weight set, we're going to use punch distance to adjust the compaction force. But for that, I'm going to use the computer. So here on the screen, we can see the main compaction force for the upper and lower punch, and then also the ejection force. Now here, with the punch distance, I can actually adjust the distance between the punches as they're going through the rollers. And so if I decrease the punch distance, I'm going to increase the compaction force. My target in this case is 5 kilonewtons. It's often good to have some set compaction forces to evaluate so that you can determine how hardness responds to compaction force. All right, so now we're hitting about 5 kilonewtons of compaction force. You can also see the ejection force on the screen. So we're in quite a nice range right now, well in the safe range. We're below 300 newtons in general. The reason there's a red bar here is actually if the ejection force gets too high, then both you'll have your tablets popping out of the die, which can damage the tablets, but also it will increase wear on your equipment. So in that case, you may need additional lubricant in the formulation. But for this formulation, we're in an excellent place for ejection force and achieving right around where we want to be for compaction force. So at this point, I can then collect some tablets for testing. So I'm going to label these for a second. Typically, I would not label them directly on the tablet, but for the purposes of demonstration, we want to keep track of these. And now I'll go on to the next compaction force. Let's increase it to 7 kilonewtons. So once again, to increase the compaction force, I'm actually decreasing the distance between the punches. So the same amount of material must be squished more to get the desired force. All right, so now we've got 7 kilonewtons. And once again, I can collect the tablets for later testing. I'm going to do this also at 10 kilonewtons and at 2 kilonewtons, and then you'll see me back for tablet testing.
In the next episode of JRS Tableting Studio, we explore the bonding mechanisms that determine tablet strength. Learn how brittle fragmentation and plastic deformation influence tablet toughness and performance on high-speed presses. JRS Tableting Studio. Stay tuned.